There are two different ways to categorize waves. We have mechanical wave versus EM wave. A mechanical wave requires a medium to travel in. A EM wave does not. A EM wave can travel in vacuum. We have transverse wave and longitudinal wave. A transverse wave has its medium's velocity perpendicular to the velocity of the wave. So a wave on a string is a transverse wave. EM waves are transverse waves. Longitudinal waves would have these two velocities parallel to each other. Longitudinal waves are usually density waves or pressure waves. So a slinky wave like this is a longitudinal wave. Sound wave is a longitudinal wave. If we have a periodic wave, this is the most important equation for the waves in sound unit. That is, the speed of a wave equals to the frequency times the wavelength. And the speed of a wave mainly depends on the medium. For a transverse wave on a string, we know that the speed of the wave equals to the square root of the tension in the string divided by the mass per unit length. So the higher the tension, the faster the speed. The heavier the rope, the denser the rope, the slower the speed. Which means the same string under a different tension is considered a different medium, which gives us a different speed. A wave carries energy. And if you remember, for a simple harmonic oscillator, the total mechanical energy equals to kinetic energy plus potential energy. And at the end point, because it's a turning point, so the speed is zero, no kinetic energy. All of the mechanical energy is in potential energy. So we have the maximum potential energy, which equals to 1/2 kx squared. And of course, at the end point, the x is the amplitude. So that means the total mechanical energy of an oscillator is proportional to the amplitude squared. For a wave, the wave intensity is defined as the power divided by the area that wave is spread out onto. And so that means the intensity is proportional to the power. Power is energy divided by time. So this is intensity is proportional to the energy, and that is proportional to the amplitude squared, so the intensity is proportional to amplitude squared. For a three-dimensional spherical wave with point wave source, the intensity, which is power divided by area, is power divided by 4 pi r squared, because the energy is being spread out onto a sphere. This means the intensity is proportional to 1/r squared, and because the intensity is proportional to amplitude squared, which is proportional to 1/r squared, if we take square root on both sides, we get amplitude is proportional to 1/r. So for a three-dimensional spherical wave, when we double the distance, the intensity becomes 1/4. And when we double the distance, the amplitude of the wave becomes 1/2.